Every application you use, your banking app, your social media feed, your e-commerce checkout, has one thing in common. Somewhere behind the scenes, there's a database storing the data. And in most cases, that database is MySQL. This chapter answers the most fundamental question. What exactly is MySQL, and why does every developer need to understand it? MySQL is a relational database management system, an RDBMS. Let's break that down. A database management system is software that lets you store, organize, and manage data. MySQL is specifically relational, meaning it stores data in structured tables, and those tables can relate to each other. The language MySQL uses to communicate is SQL, Structured Query Language. SQL is how you tell MySQL what to do. Give me this data, store that data, update this record, delete that row. MySQL is the engine. SQL is the language you speak to it. And with MySQL, you can store application data, retrieve it quickly, update existing records, delete what you no longer need, and manage enormous data sets efficiently. SQL was designed to read like English, and it does. Select star from users means give me everything from the users table. Delete from users where ID equals 1 means delete from users the row where the ID is 1. Even non-developers can often read SQL and understand it. Every database application is built on 4 operations: create, read, update, and delete, what developers call CRUD. Insert is create, select is read, update is update, delete is delete. Every feature in every web application ultimately maps to one of these 4 operations. And when your Laravel application sends a query to MySQL, MySQL parses it, finds the data, and returns results in milliseconds, even against tables with millions of rows. MySQL is everywhere. Web applications, it stores users, posts, comments, orders, sessions, anything that needs to persist between page loads. Enterprise systems, CRM platforms, HR tools, inventory management, financial systems handling millions of records daily. Content management systems, WordPress, Drupal, and Magento all run on MySQL. Every blog post, every product listing, every page is a row in a MySQL table. Data platforms, analytics, dashboards, and reporting tools use MySQL to store and query structured data sets. And MySQL integrates with every backend language: Laravel, PHP, Node.js, Python, Ruby on Rails. Whatever you build with, MySQL speaks to it. Let's anchor the key facts. MySQL is an open-source relational database management system. It stores data in structured tables. It uses SQL as its language, and it is the foundation of modern web development, used by millions of apps worldwide. Free forever, fast enough for enterprises, and the first database most developers learn. Chapter 1 of 10. MySQL was built in 1995. 30 years later, it is still the most widely deployed open-source database in the world. That does not happen by accident. This chapter covers who built it, how it got to where it is today, and the 5 specific reasons it became the default database for developers everywhere. MySQL was created in 1995 by 3 developers: Michael Wydenius, known as Monty, David Axmark, and Alan Larson. They founded a company called MySQL AB in Sweden. Their goal was simple: build a database that was fast, reliable, and easy to use, a reaction against the complexity and cost of existing database solutions at the time. The name MySQL comes from Monty's daughter, Mai. In 2008, Sun Microsystems acquired MySQL AB for approximately $1 billion, bringing significant enterprise resources to the project. Then, in 2010, Oracle Corporation acquired Sun Microsystems, and MySQL came with the deal. Oracle maintains MySQL today, offering both a free Community Edition and a paid Enterprise Edition. The Community Edition is production-ready and completely free. 5 reasons MySQL is the world's most popular open-source database. 1. It is open source, free to download, use, and deploy. No license fees, no per-user costs, no vendor lock-in. This alone makes it the default choice for developers and startups. 2. High performance. MySQL is optimized for speed.
advanced indexing, query caching, and choice of storage engines. With proper indexes, queries against millions of rows return in milliseconds. 3. Scalability. MySQL works for a personal blog with 100 rows and for platforms handling billions of rows. The same SQL commands work at both scales. 4. Security. Built-in user authentication, role-based access control, SSL encryption, and data-at-rest encryption. You can grant fine-grained permissions. This user can only select from this table. That user has no access to salary data. 5. Community. Millions of developers worldwide, extensive documentation, hundreds of thousands of Stack Overflow answers. Whatever problem you hit, someone has already solved it. Let's go deeper on performance. The key to MySQL's speed is indexes. An index works like a book index. Instead of scanning every row to find a matching record, MySQL jumps directly to it. Without an index on email, finding a user scans every row in the table. With an index, it finds the row in microseconds regardless of how many rows exist. MySQL also supports multiple storage engines. NoDB is the default. It supports transactions, foreign keys, and row-level locking, which are essential for any serious application. For scaling, MySQL supports primary replica replication. One primary database handles all writes. Multiple read replicas handle select queries. As traffic grows, add more replicas. The scaling strategy is predictable. Small, single server with good indexes. Medium, read replicas and query optimization. Large, sharding and clustering. The same MySQL throughout. The MySQL community is one of its greatest strengths. The official documentation at dev.mysql.com is one of the best documented open source projects in existence. Every command, every configuration, every function has detailed examples. Stack Overflow has over 650,000 MySQL questions. Whatever problem you encounter, the answer is almost certainly already there. The tooling ecosystem is rich. MySQL Workbench, PHP Admin, Table Plus, DataBeaver, DataGrip, GUI tools for every skill level. And framework integration is first class everywhere. Laravel's Eloquent ORM, Django's ORM, Rails Active Record all have built-in MySQL support. You rarely write raw SQL in a modern framework. The ORM translates your objects into optimized queries automatically. MySQL wins because of 5 things. It is open source and free. It is fast with proper indexes. It scales from small to enterprise. It is secure with built-in access control, and it's backed by millions of developers and the best documentation in the industry. Built in 1995 by MySQL AB, acquired by Sun in 2008. Maintained by Oracle since 2010, still the standard today. Chapter 2 of 10. Before you write a single SQL query, you need to understand how MySQL organizes data. Every database, no matter how complex, is built from the same 3 things: tables, rows, and columns. Once you understand these 3 concepts, every SQL command you learn will make immediate sense. Let's build the mental model from scratch. A table is the fundamental unit of a MySQL database. Think of it exactly like a spreadsheet. The column headers define what kind of data each column holds. Each row underneath is one complete record. In our users table, the columns are ID, name, and email. Row 1 is John Doe with his email. Row 2 is Sarah Smith. Row 3 is Mike Johnson. Table, users. Rows, records, each one a single user. Columns, fields. ID, name, email are the 3 fields every user record has. The difference between a MySQL table and a spreadsheet is that MySQL enforces strict types and rules on every column. You cannot store a phone number in an integer column. You cannot leave out a required field. MySQL validates data at the storage level. Every table needs a primary key. The primary key is a column, usually named ID, that uniquely identifies every row. No 2 rows can share the same primary key. It can never be null. In our users table, ID is the primary key. John is ID 1. Sarah is ID 2. Mike is ID 3. When you mark a column as auto-increment primary key, MySQL assigns the next number automatically every time you insert a row. You never set the ID manually. Insert John, MySQL gives him ID 1. Insert Sarah, ID 2. Delete Sarah, The next insert gets ID 3, not 2. IDs never reuse. Primary keys also enable relationships. When the orders table needs to reference a user, it stores that user's ID in a column called user ID. That reference of foreign key is how MySQL tables talk to each other. Important rule: never use meaningful data as a primary key. Names change, emails change. A primary key should never need to change because every table that references it would also need to update. Every column in a MySQL table has a data type, and MySQL enforces it. INT stores whole numbers, ages, quantities, IDs, no decimals. Varchar stores variable length text up to a maximum you define. Varchar of 255 is the most common choice for names and emails. Text stores long text with no fixed limit, blog posts, descriptions, comments. Decimal stores precise decimal numbers. Use this for prices and currency. Never use float for money. Floating point binary cannot represent 0.10 exactly, and 0.1 plus 0.2 in float can equal 0.3000000000010. A single rounding error across thousands of transactions adds up to real money lost. Boolean stores true or false. Is active, is admin, is verified. Datetime stores date and time. Created at, updated at. The discipline of choosing the right type for each column reduces storage, improves index performance, and makes the schema self-documenting. A tiny int age column tells the next developer exactly what range to expect. Real databases have many tables, and those tables relate to each other. Our users table has John with ID 1 and Sarah with ID 2. Our orders table has 3 orders. Order 1, user ID 1, laptop, $999. Order 2, user ID 1, mouse, $29. Order 3, user ID 2, keyboard, $79. John placed 2 orders, Sarah placed 1. The orders table never stores John's name or email, it only stores his ID. When you need to display his name next to an order, you join the 2 tables at query time. This is database normalization. Store each piece of data in exactly one place. If John changes his email, you update it in one row in the users table. Every order automatically reflects the new email because orders reference his ID, not his email directly. Schema design, deciding which tables to create, what columns they have, and how they relate is one of the most valuable database skills you can develop. A good schema makes every query simple. A poor schema makes every feature a struggle. A table contains rows. Rows have columns. Every table needs a primary key. Tables relate to each other through foreign keys. Every column has a type that MySQL enforces. Design your schema carefully. It is the foundation everything else is built on. Table, row, column, primary key, foreign key, data type. Chapter 3 of 10.
MySQL is not just a collection of tables floating in space. Everything has a place and a strict hierarchy. Once you understand the 5 levels, server, database, table, row, column, you understand exactly how MySQL organizes data and exactly where every command you write fits. Let's map the full structure from top to bottom. 5 levels. At the top, the MySQL server, the running software process listening on port 3306. Below that, databases, named containers. Each database holds tables. Each table holds rows. Each row has columns. In our example, the MySQL server hosts company_DB. Company_DB contains an employees table. The employees table has rows. Row 1 is John, developer, salary $75,000. Row 2 is Sarah, PM, salary $82,000. And each row has columns: ID, name, role, salary. A single cell at the intersection of a row and a column holds one value. John's salary is the value at row 1 salary column, $75,000. One MySQL server can host as many databases as you need, and each one is completely isolated. Company_DB holds employees, departments, and projects. Shop_DB holds users, orders, and products. Blog_DB holds posts, comments, and tags. Tables in company_db cannot directly reference tables in shop_db. Each database is a separate namespace. The convention is one database per application. Your Laravel app gets one database. Your WordPress install gets another. They all live on the same MySQL server, but operate independently with separate access controls and separate table namespaces. In Laravel, the use command is handled automatically. Your .env file's db_database setting tells the framework which database to operate in. Here is what a real Laravel applications database looks like. The users table, ID, name, email, password, email verified at, created at, and updated at. The posts table, ID, user ID, title, body, published at, created at, and updated at. The comments table, ID, post ID, user ID, body, created at, updated at. Notice the relationships in the column names. Posts has user ID. Comments has both post ID and user ID. These foreign keys make the table relationships visible at a glance. Notice also that every table has created at and updated at. Laravel's Eloquent manages these automatically. And the migrations table. This is how Laravel tracks which schema changes have been applied. Every time you run PHP artisan migrate, Laravel checks this table to know which migrations are new. The MySQL commands map directly to the hierarchy. Create database creates level 2, the container. Use selects it, sets the context for all future commands. Create table creates level 3, the structure. Show databases lists all databases on the server. Show tables lists all tables in the current database. And describe table name. This is one of the most useful commands a developer can run. Describe employees returns every column name, its data type, whether it allows null, whether it's a key, its default value, and any extra settings like auto increment. It is the fastest way to understand a table structure without reading the original migration. The MySQL server hosts databases. Databases contain tables. Tables contain rows. Rows have columns. 5 levels. Every command you write operates at one of those levels. Create database at level 2. Use to select it. Create table at level 3. Insert, select, update, delete at levels 4 and 5. Show and describe to navigate and explore. Chapter 4 of 10. Part 1 of SQL commands covers the first half of CRUD, creating structure and adding data. 3 commands. They always run in the same order. By the end of this chapter, you will be able to take an empty MySQL server and build a populated database from scratch. Let's go. 2 commands before you can do anything else. First, create database. 1 command, 1 database created. Run it once at the start of a project. After this command, the database exists, but it is completely empty. No tables, no data, just the container. Second, use. This tells MySQL which database all future commands operate within. If you forget to run use, MySQL returns no database selected. Every session starts without a context. Use sets it. In tools like phpMyAdmin, clicking on a database in the sidebar runs use automatically. Pro tip, add if not exists to create database. Create database if not exists company_db, and the command is safe to run multiple times. If the database already exists, MySQL skips it without an error. Create table defines the structure of your data. The command opens with the table name. Then inside parentheses, you list every column, its name, its data type, and any constraints. The ID column, int for whole number, auto increment so MySQL assigns the next value automatically, primary keys so it is unique and indexed. The name column, varchar of 100 characters, not null so every user must have a name. The email column, varchar of 150, not null and unique, no 2 users can share an email. The age column, just int, no not null, it is optional and can be null. The isActive column, Boolean with a default of true, new users are active unless you say otherwise. The created_at column, date time, default current timestamp. MySQL automatically records the exact time each row was inserted. You never have to set it manually. Insert into adds rows to a table.
The syntax: insert into, table name, then in parentheses the columns you are providing values for, then values, then the data in matching order. You do not list ID, it is auto-increment. You do not list is active, it has a default. You do not list created at, it defaults to now. Only provide values for the columns that need them. For multiple rows, one insert statement, multiple value sets separated by commas. Inserting 1,000 rows in one insert is dramatically faster than 1,000 separate insert statements. Each individual statement has parsing overhead, planning overhead, and a network round trip. Batch your inserts whenever loading data in volume. And when you insert, every constraint fires. Not null checks, unique checks, foreign key checks, type checks. If any constraint fails, the entire insert is rejected and nothing is written. Here is the complete sequence. Step 1, create database shop_db. The container exists. Step 2, use shopdb. All future commands operate here. Step 3, create table products. ID, int auto-increment primary key. Name, varchar 200 not null. Price, decimal 10, 2 not null. Stock, int default 0. The structure exists. Step 4, insert into products, name, price, stock, values, laptop 999.99, 50, mouse 2999, 200. The data exists. After these 4 steps, shopdb has one table with 2 rows. Laptop is ID 1 with 50 in stock. Mouse is ID 2 with 200 in stock. In Laravel, steps 1 and 2 are handled by your setup. Steps 3 and 4 are what migrations and seeders do, but now you understand exactly what they're executing. 4 commands. Create database makes the container. Use selects it and sets the context. Create table defines the columns, types, and constraints. Insert into adds rows one at a time or in batches. Always in that order. Always with where on writes. Chapter 5 of 10. Chapter 5 covered creating structure and adding data. Chapter 6 completes CRUD. Select reads data. Update changes it. Delete removes it. And where makes all 3 precise. These 4 operations, combined with the 4 from Chapter 5, give you everything you need to build real applications on MySQL. Let's finish CRUD. Select is the most important and most used SQL command. You will write select thousands of times in your career. Select star from users returns every column and every row. Select name, email from users returns only those 2 columns. In production, prefer listing specific columns rather than star. It transfers less data and makes your code explicit about what it actually needs. Add where to filter. Select star from users where ID equals 1. Returns just that one user. Add order by to sort. Order by name, ASC, returns users alphabetically. Add limit to cap results. Limit 10 returns only the first 10. Combined, order by created at, DESC, limit 10 returns the 10 most recently created records, the backbone of every recent items list in every web app. Select also works with aggregate functions. Select count star from users tells you how many users exist. Select AVG of salary from employees gives you the average salary. Select sum of total from orders where user ID equals 1 tells you how much one user has spent. Where is the filter clause, and it works on select, update, and delete equally. Where ID equals 5. Exact match. Where age greater than 25. Comparison. Where name like John %. Matches anything starting with John. The % sign is a wildcard, meaning any characters. Where age between 20 and 30, a range. Where role in parentheses admin editor matches either value in the list. Where email is not null finds rows where the column has a value. And requires both conditions true, or requires at least one.
where age greater than 18 and is active equals 1 returns only adult active users. Use parentheses when combining and or to make precedence explicit. A complex where clause is just a precise description of exactly which rows you want. Update changes existing rows. The syntax, update, cable name, set, column equals value, where condition. Update users set name equals John Smith, where ID equals 1. Updates exactly one row. Set can change multiple columns at once. Set name equals Sarah Jones, age equals 32. Every column in the set list is updated for every row matching the where condition. The golden rule: every update must have a where clause. Without where, every row in the table is updated. Delete removes rows. Delete from users where ID equals 3 removes exactly one row. And this is the most important wording in all of MySQL. Delete from users with no where clause deletes every single row in the table, instantly, permanently, with no confirmation prompt and no undo. Develop the discipline of writing the where clause first before the delete. Many production systems avoid delete entirely. Instead, they use soft deletes, setting a deleted at column to the current timestamp. The row remains in the table but is filtered out of all queries. Laravel's soft deletes trait implements this pattern automatically. 7 commands: create database, use, create table, insert into, select, update, delete. This is CRUD complete. Create maps to insert into. Read maps to select. Update maps to update. Delete maps to delete. Every feature in every web application you ever build, user registration, login, profile update, post creation, order placement, account deletion, maps to one of these 4 operations on a database table. Master these 7 commands and you have the foundation to build anything. The remaining chapters build on top of this foundation: how MySQL works with web apps, the tools, when to use it, and how it all fits together. Chapter 6 of 10. Select reads data. Where filters it with comparisons, ranges, patterns, lists, and null checks. Update changes values, always with where. Delete removes rows, always with where. Always. CRUD is complete. 7 commands, the foundation of every database-driven application ever built. Chapter 6 of 10.
Every web request ends up in a database. When someone visits your site, logs in, submits a form, or loads a page, MySQL is working. This chapter maps the full journey from browser to database and back and shows exactly how Laravel sits in the middle of that cycle. Here is what happens when a user visits /users/1. Step 1. The browser sends an HTTP GET request. Step 2. The web server, Apache or Nginx, receives it and routes it to PHP and Laravel. Step 3. Laravel runs user : find of 1. Eloquent translates this into a SQL query. Step 4. MySQL executes select star from users where ID equals 1, finds the row and returns it to PHP. Step 5. Laravel builds an HTML page from a Blades template using the data. Step 6. Apache sends the HTML response back to the browser, which renders the page. This cycle, 6 steps, runs for every single page load. A typical page might trigger 5 to 20 database queries. The user profile, their posts, their notifications, each is a separate select query. The page only renders after every query has returned. A slow query makes a slow page. Query performance is not an advanced topic. It is a core web development skill. Laravel uses an ORM called Eloquent. ORM stands for Object Relational Mapper. It maps database rows to PHP objects. User : find of 1 becomes select star from users where ID equals 1. User : where active, 1 gets becomes select star from users where active equals 1. User : create with name John becomes insert into users name values John.
You work with PHP objects, and Eloquent generates the SQL. Understanding the SQL it generates makes you significantly better at using Eloquent. You know what is happening, why it might be slow, and when to optimize. The most common performance mistake in Laravel is the n+1 query problem. Loading 100 users, then calling $user arrow posts in a loop. That's one query for users plus 100 queries for posts, 101 total. The fix is eager loading. User : with posts get 2 queries regardless of how many users. The Laravel debugger back package shows every SQL query a page generates, query text, which line triggered it, and how long it took. Install it in development. 6 lines in your .env file connect Laravel to MySQL. db connection equals MySQL tells Laravel which driver to use. db host equals 127.0.0.1, where MySQL is running, local in development. db port equals 3306, MySQL's default port. db database equals shopdb, the database name. Laravel runs use shopdb automatically. db username and db password, the MySQL user credentials. That is the entire connection. Never commit .env to version control. It contains credentials. Migrations are Laravel's version control for database schema. Instead of writing raw create table SQL, you write migration files in PHP. PHP artisan migrate runs all pending migrations. PHP artisan migrate rollback reverses the last batch. The schema is tracked alongside application code and get. Seeders run insert into statements to populate tables with test data. PHP artisan db:/seed fills your development database in one command. Let's trace a complete feature: user registration. Step 1, the user fills in name, email, and password and submits the form as a post request. Step 2, Laravel validates the input. Is the email a valid format? Is the password at least 8 characters? Is the email unique in the database? Step 3, the password is hashed with bcrypt. Never store plain text passwords. Step 4, MySQL executes insert into users with the name, email, hashed password, and the current timestamp. The unique constraint on email fires here. If the email already exists, MySQL rejects the insert and Laravel returns a validation error. Step 5, the user is logged in and redirected to their dashboard. This same pattern, form, validate, hash or sanitize, query, respond, is every feature in every web application ever built. Every web request triggers SQL queries. Laravel connects to MySQL via 6.env values. Eloquent translates PHP method calls into SQL automatically. Migrations version your schema in Git. Seeders run insert into statements to populate development databases. Every feature maps to CRUD on MySQL tables. Browser, PHP, MySQL. The same 3 layers every time. Chapter 7 of 10.
You know the SQL. Now you need the tools to work with it efficiently. This chapter covers the MySQL command line, the major GUI applications, and how to choose the right tool for each situation. The good news, every tool runs the same SQL underneath. Learn one well, and the skill transfers to all of them. The MySQL CLI is installed with MySQL and available on every server. Connect with MySQL-u root-p. The -p flag prompts for your password. Once connected, you're at the MySQL prompt. Everything you have learned works here directly. Show databases, use, create table, select, insert, update, delete. Show databases lists everything on the server. Use database name selects it. Show tables lists all tables. Describe table name shows the full column structure. The CLI is the tool you reach for when SSH'd into a remote server, running migrations in production, or importing large SQL files. MySQL dump -u root-p database name redirect to backup.sql creates a complete database backup. MySQL -u root-p database name redirect from schema.sql imports one. These commands power deployment scripts and backup systems worldwide.
Every developer should be comfortable with the MySQL CLI. It is the one tool guaranteed to be available on every server. 5 GUI tools cover every situation. PHP MyAdmin, web-based, free, comes pre-installed with every hosting panel, XAMPP, MAMP, cPanel. Access it in a browser, no installation. MySQL Workbench, official GUI from Oracle, free, desktop application, full schema design with visual entity relationship diagrams, query editor, performance dashboard. Table Plus, the favorite of modern developers, native app, fast, beautiful UI, supports MySQL and PostgreSQL and SQLite in one tool, inline row editing, SSH tunneling. Paid, but a free tier with limited tabs is available. VS Code, the database client and SQL tools extensions bring MySQL directly into your editor. Query results in a side panel, write code and inspect data in the same window. dbeaver, open source, cross-platform, supports every database engine, popular in enterprise teams that work with multiple database types. PHP MyAdmin is the tool most PHP developers encounter first, and for good reason. It ships with every hosting panel in existence. Browse any table, see all rows, sort by column, edit cells in line, add rows through a form. The SQL tab lets you write and run any query, results appear in a table below it. Import and export to .sql files, the standard way to move databases between environments. The Structure tab shows all columns, types, and indexes. Most importantly, PHP MyAdmin shows the SQL it generates for every GUI action. When you click to delete a row, it shows you the delete statement. When you edit a cell, it shows the update. Reading these generated queries is one of the best ways to learn SQL when you are starting out. Security note, PHP MyAdmin gives full database access to anyone who can reach it. On production servers, restrict access by IP address, add HTTP authentication, or disable it entirely. Use the CLI when you are SSH'd into a remote server, running production migrations, importing large SQL files, or scripting automated tasks. Use PHP MyAdmin when you are on shared hosting, need a browser-based tool, or are doing a quick import or export. Use Table Plus for daily local development work. It is the fastest and most polished desktop experience. The developer recommendation, Table Plus or MySQL Workbench for local development, MySQL CLI for all server work, PHP MyAdmin for hosting panels, VS Code extension if you prefer to stay in your editor. Every tool runs the same SQL. Learning SQL means you're never locked into any GUI. Switch tools at any time. The knowledge transfers completely. CLI for servers, GUI for daily work. All tools run the same SQL. 5 tools. The CLI for remote servers and scripts, PHP MyAdmin for web-based and hosting environments, MySQL Workbench for full-featured free desktop work, Table Plus for fast, modern daily use, VS Code extension to stay in your editor. Learn one well. The skill transfers to all of them. Chapter 8 of 10.
LAMP, 4 letters, one of the most important technology stacks in the history of the web. Linux, Apache, MySQL, PHP. This is the foundation that WordPress, Drupal, Laravel, and millions of custom applications are built on. This chapter explains what LAMP is, when MySQL is the right choice, and the rare situations where you should reach for something different. 4 layers, each doing one job. L. Linux, the operating system. Ubuntu, Debian, CentOS. Runs on the server, hosts everything else. Free, stable, secure, the standard server OS. A. Apache, the web server. Receives HTTP requests from browsers, routes them to PHP, returns responses. Nginx is a popular modern alternative, which is why you also see LEMP, Linux, Nginx, MySQL, PHP. M. MySQL, the database, stores all persistent data, users, orders, posts, settings, runs alongside Apache, responds to PHP queries in milliseconds. P. PHP, the programming language, processes requests, queries MySQL, builds HTML, returns responses. Laravel runs on PHP, WordPress runs on PHP.
The full cycle. Browser sends a request. Apache receives it and passes it to PHP. PHP queries MySQL. MySQL returns data to PHP. PHP builds the HTML response. Apache sends it back to the browser. All of this running on Linux. Use MySQL when your data has a clear, consistent structure. Users, orders, products, posts. Data that fits neatly into rows and columns with predictable relationships. If your data looks like a spreadsheet, MySQL is purpose-built for it. Use MySQL for web applications and CMS platforms. The entire PHP ecosystem is built around MySQL. Every hosting environment, every Laravel tutorial, every WordPress plugin assumes MySQL. Use MySQL when transactions are required. Order processing, payments, inventory updates, operations where multiple steps must all succeed or all fail together. MySQL's InnoDB engine provides full ACID compliance, atomicity, consistency, isolation, durability. These properties guarantee your data stays correct even if the server crashes mid-transaction. Use MySQL when you need to query and filter data precisely. Reports, dashboards, search filters. SQL's where, join, group by, and order by give you surgical control over exactly which data to retrieve. 3 situations where MySQL is the wrong tool. First, unstructured or rapidly changing data. If every record looks different or your data structure changes constantly, a document database like MongoDB is a better fit. MySQL tables have fixed columns. Rigid structure becomes a liability when your data has no consistent shape. Second, extreme write throughput at massive scale. Real-time analytics, IoT sensor data, millions of events per second. Time series databases like InfluxDB or Cassandra are purpose-built for this. MySQL can be pushed hard, but it is not designed for pure write-at-scale workloads. Third, highly connected graph data. Social networks, recommendation engines, fraud detection, data where the relationships between entities matter more than the entities themselves. Graph databases like Neo4j model this naturally. But here's the important context. These 3 edge cases cover a tiny fraction of real-world web development. For the vast majority of applications, MySQL is exactly the right choice. LAMP has evolved. LEMP, Linux Nginx MySQL PHP, is the modern production favorite. Nginx handles concurrent connections more efficiently than Apache and uses less memory. Most new Laravel deployments use LEMP rather than LAMP. For local development, XAMPP installs Apache, MySQL, and PHP in one click on Windows, Mac, and Linux. MAMP is the Mac-focused equivalent. Laragon is the fastest Windows setup for Laravel development. Modern teams often use Docker. MySQL runs in a container alongside PHP and Nginx, matching the exact production environment. Laravel Sail provides a pre-configured Docker setup. Cloud MySQL is now mainstream. AWS RDS, Google Cloud SQL, PlanetScale, Railway, managed MySQL with automated backups and scaling. The only difference in your application is the connection string in .env. MySQL is the default everywhere PHP runs. Every hosting provider supports it. Every team uses it. Learning MySQL means you can work with any PHP project on any server anywhere in the world. LAMP, Linux, Apache, MySQL, PHP, the classic stack that powers the majority of the web. Use MySQL for structured data, web applications, transactions, and precise queries. Avoid it for unstructured data, extreme write throughput, and graph data, but those are rare cases. LEMP is the modern evolution. Cloud MySQL removes the server administration burden. MySQL is the default everywhere PHP runs. 1 chapter left. Chapter 9 of 10.
10 chapters, 1 complete picture. Let's take a moment to see how far we've come, from understanding what a relational database is all the way to deploying MySQL in a LAMP stack web application. Every concept builds on the one before it. 7 commands power everything MySQL does. Create database makes the container. Use selects it. Create table defines structure. Insert into adds data, that's create in CRUD. Select reads data with where, order by, and limit, that's read. Update changes values, always with where, that's update. Delete removes rows, always with where, never without it, that's delete. 7 commands, the entire database. The mental model. Server contains databases, databases contain tables, tables contain rows, rows have columns. Every table needs a primary key. int auto increment primary key. It uniquely identifies every row. Foreign keys link tables together. Orders.user_id pointing to users.id. Use the right data types. int for numbers, varchar for short text, decimal for money, never float, and datetime for timestamps. In a web application, MySQL sits at the center of every request cycle. Browser to Apache to PHP to MySQL and back. Laravel connects via 6.env values. Eloquent writes the SQL. Migrations version the schema. The LAMP stack, Linux, Apache, MySQL, PHP is the classic foundation. LEMP replaces Apache with Nginx for modern deployments. CLI for servers. phpMyAdmin for hosting, Table Plus for daily work. All run the same SQL. 10 rules to work confidently with MySQL. 1. Always add a primary key. 2. Always use where on update and delete. 3. Use decimal for money. 4. Add unique constraints where needed. 5. Use foreign keys. Don't duplicate data. 6. Add indexes on columns in where and join. 7. Always add created at and updated at timestamps. 8. Use soft deletes in production. 9. Never commit .env to version control. 10. Use migrations. Never alter a production schema manually. MySQL is an open-source relational database. It stores structured data in tables. SQL reads, updates, and deletes it. The LAMP stack serves it to the world. 10 chapters, 7 commands, 5 hierarchy levels, full CRUD. The LAMP stack, 10 golden rules. You now know MySQL. Series complete.